Sixth grade, lesson 8.4, we're going to be solving addition and subtraction equations. You're going to learn how to use inverse operations to solve for a variable. And the properties you'll use are the subtraction property of equality and the addition property of equality, which I'll show you. And hopefully you'll find this makes pretty good sense. Okay, so subtraction property of equality is just stating that if you subtract the same exact number from both sides of an equation, both sides of the equal sign, the two sides of the equation will remain equal. And of course, there is their example, they use 3 plus 4 equals 7. And of course, you recognize that. You know 3 plus 4 equals 7. But this is what they use to prove it. If we always think of our equations as a balanced scale, then whatever you do to one side of the scale, you must do to the other side of the scale. So it's good to get into your mind that scale sitting there. And so what they're saying is, if I have 3 here and I'm adding 4 to it, I can subtract 4 from here. And the subtraction property of equality says, if I subtract 4 from here and I also subtract 4 from here, I maintain the equality of the equation. If I take 4 off of this side of the scale, I'm taking 4 side off that side of the scale to keep it balanced. So if I do that, let's do this, subtract 4 from this side and also subtract 4 from that side, you will see positive 4, negative 4 cancel each other out. And 7 minus 4 is 3. And in fact, that is the truth. 3 does in fact equal 3. So knowing that that is something we can use, if we find ourselves in a situation where one of these two is a variable, an unknown number, we could use that property to our advantage. And so here's an example of that. And this is the longest distance jumping on a pogo stick is 23 miles. This is from the Unlock the Problem. Emilio has jumped 5 miles on a pogo stick. Can you imagine 5 miles on a pogo stick? Let alone 23 miles. The equation d plus 5 can be used to find the remaining distance in miles. He must jump to match the record. We don't know how far he needs to go, but add 5 to it, and it will total the 23, the goal. So I can solve for that. If I know my subtraction property of equality, I can use that, using that inverse operation, that opposite operation, to isolate my variable. So my goal is to always get on its own side of the equation. So I have two sides of the equation. Remember, I want them to act like a balanced scale. Whatever I do to one side, I must do to the other. And I want to use the inverse, the opposite, the undoing of this plus 5. The opposite of that is to take those 5 away. So if I subtract 5 here, I would get d by himself, and that's my game. That's my goal. I want to isolate the variable d, get him by himself on his side of the equation. My issue is I can't just take 5 off there. I go out of balance, right? So I must take 5 off of the other side, and I can do that because the subtraction property of equality. It will remain equal as long as I do the same to both sides, as long as I keep my scale balanced. Okay, then I get plus 5 minus 5 cancels out, so it would end up being d plus 0, which of course you know, anything plus 0 is just itself, identity property of addition. And then 23 minus 5 would give me 18. So I can isolate the variable and find out what the value of it is as long as I have enough information. And so this property allows us to work those numbers so that they work for us. All right, and so also there is an addition property of equality. It's the same idea, so pretty easy to pick up from here. If you add the same number to both sides of the equation, the two sides will also remain equal. So it's still that idea of this balanced scale that you have. There's the two sides of the scale, and that equal sign is where we want that to stay balanced. So this is the values they use to prove this to you. I have the 7 and I have a minus 4. Well, if I add 4, the inverse of minus 4 is to add 4. So if I add 4 to this side, it will be back at 0 again. And I am allowed to do that because this property says as long as I do that to the other side of the equation to keep things balanced, that's fine. Well, a minus 4 and a plus 4 cancels each other out to give me 0. So I would have 7 plus 0, which of course is 7. And 3 plus 4 on this side is 7. And so yes, there's the proof that that works. So let's see an example of that happening. Okay, and this one with decimals even. Oh no. Here is my scale, the two sides of the equation, like a scale. Some people like to put a wall down there so they know which the two sides are, or you could write the scale real lightly underneath. Okay, and so I want to choose the side of the equation, the side of the scale that has the variable. And here is the variable. So that's the focus side. And I want to isolate this variable. He likes to be a loner. I want to get him by himself, but hanging out with him is this minus 14.9. Let's do the opposite, the inverse of minus 14.9. We will add 14.9. If I add 14.9 to this side of the equation, then I have to do the same to the other side of the equation, or else I ruin it. That cancels out. It leaves me with W isolated. That's what I wanted. Then I just simply need to add these up. 9 plus 3 is 12. Decimal. 5 plus 4 is 9 plus 1 more is 10. 2 plus 1 is 3 plus 1 more is 4. So W must equal 40.2. And so I chose this one on purpose. I chose it because it did have the decimals involved. I also chose it because it had the variable on that side of the equation rather than this side like you have been seeing. And I just wanted you to see it doesn't matter where your variable is at. Just locate it, and then your job is to isolate him by himself. So do inverse operations to isolate him by himself. Okay, this example gets us that chance to practice those word problems and those fractions. They give us the equation, but let's take this opportunity to walk ourselves through how they get to that equation. Translation with no stress involved. So all of our steps, we read it, we underline the question, circle the information they gave us, and draw it. So while cooking dinner, Carla pours 5/8 cup of milk from a carton. This leaves 7/8 cup of milk in the carton. Write and solve an equation to find how much milk was in the carton when Carla started cooking. We read it. Let's underline the question they want me to write and then solve the equation. Circle the information. She poured out 5/8 cup of milk from the carton, and still left in there is 7/8 cup of milk in the carton. Well, let me draw a carton of milk. Okay, pretend that's a carton. She poured out 5/8 cup, so that came out of there. And what's left is 7/8 cup still in there. What we don't know is how much was in there in the beginning. And so that's what we're trying to find out, and that's the unknown number. So there's our variable. So we're going to they chose A as a variable. Let A represent the amount of milk in cups that are in the carton when she started cooking, before she poured anything out. So if we started with A, and then we took some out, that much out, then what's left is this amount. And so hopefully you can see that sometimes when you draw those pictures, it helps to make sense of everything. So here's our equation. That's what we came up with. So A minus 5/8 equals 7/8, what's left in the end. Now, in previous lessons, it was like, okay, that's it. But here now we know how to go about solving these. So if I have, and I know the fractions have you a little nervous, no worries, this will take you through it too. If I have A, well, let's do it this way. Let's let you see it on that scale, because you're getting used to it seeing on the scale now, I think. So we have our scale, the two expressions on either side of the equal sign that we want to stay balanced. And my goal is to isolate the variable, get him all by himself. Well, minus 5/8 is happening here. So what's the inverse of minus 5/8 to get it to go away? It's add 5/8. And I'm allowed to do that as long as I do the same thing to the other side of the equation. Now this minus 5/8 and plus 5/8 cancels each other out to 0. So now I do have a isolated. A plus 0 is just a. And I'm going to take 7/8 plus 5/8. Oh, and thankfully we have common denominators already. So we just do 7 plus 5, which is 12 eighths. Recall this is an improper fraction, so we're just going to do division of the bottom number into the top number. The remainder becomes the numerator, so 8 goes into 12 once, and there will be 4 left out of the 8. And remember to reduce those fractions if they're reducible. 4/8 can be reduced. 4 divides into both of these, once into 4 and twice. It's 1/2, so 1 1/2 cup. So we've added 5/8 to both sides. That's what we did here. They just did it side by side. We did it one below the other. And that left us with a equals 12/8. But we converted that improper fraction just to practice that skill. And we reduced the fraction just to practice that skill. So she started with 1 1/2 cup of milk in the pitcher, or in the carton. So there was 1 1/2 cup of milk in the carton when Carla started cooking. And so most of what you're covering today in your share and show and the on your own is just practicing. They give you the equation, and then you're using that inverse operation to isolate the variable. Get that variable by himself so you can find out what he is. You're a detective, a math detective today. Go ahead, give it a shot. I think you're going to do really well. I think you'll pick it up very quickly.